Ladies and gentlemen, we are now starting the second session of the symposium. We would like to invite Dr. Ayarit Taipistiko from Siriraj Hospital, Mahidol University, Thailand, and Dr. Safarina Malik from Muhtariad Institute for Nanotechnology Indonesia to moderate this session. Dr. Ayarit, the time is yours.
Okay, thank you very much. Greeting from Bangkok, and I will be the host for the session 2 for today's conference. So our guest, the first speaker is Dr. Yuan Kun from National University of Singapore. All right, good morning, Dr. Lee. It's been a while.
Nice seeing you again. Nice seeing you in person.
All right, so the floor is yours.
Thank you very much. Thank you. Let me share the slides.
While waiting, because Dr. Lee cannot stay for our question and answer session, so we will have the questions for Dr. Lee right after his talk.
Sorry, I have a bit of problem in. Oh yes, it's here.
Yuan Kun, can you share
your?
See
my?
No, we have. You should click share screen and choose your slides.
Sure. Okay. The
share screen.
Sorry that I thought I have already shared. Yes. Share screen. Yes.
And choose your slides. Okay, now we can.
Are you able to see now? Okay. Are you able to see the screen?
Yes.
Right. I'll start then. Thank you very much for inviting to share our data and experience. The Asian Microbiome project was initiated in 2000. Sorry. Here. Oh. All right. Was initiated in 2009 under the auspice of the Asian Federation Society of Lactic Acid Bacteria. Initially, 10 country regions in Asia participate in it. You can see that from Japan, Korea, Mongolia, Taiwan, China, Philippines, Malaysia, and Singapore. The effort proved to be most rewarding, as can be seen in the right-hand side of the graph. We see clear regional demarcations of the enterotypes of people in Asia, starting from the Eastern Asia, where you can see that most of the people are of the Bacteroides and Bifidobacterial types, which is shown as yellow here, to the Southeast Asia of the green, which is the Brevotella types. Right. As you can imagine, we spent more than 2 years in harmonizing the technologies and training of technical staff are involved in it, and we put in a lot of effort as well to resolving administrative issues such as collection of samples, sharing of know-how, sharing of samples, and transportation across the border. Nevertheless, as said, the effort proved to be most rewarding. And when we put our finding on the world map together with other works in microbiome and part of the world, we saw interesting profile and trends. As can be seen here, you can see here all the cycles represent the different proportion of microbiome among the in the gut samples. As if you can see here in the northern hemisphere, the microbiome and people are dominated by Bacteroides, which is shown as orange in the pie chart. And whereas in Eastern Asia, you can see that Bifidobacterium are also in abundance as well. And interestingly, in the southern hemisphere, the people are dominated by the green color microbiome, which is the Brevotella cae. And I want to point out two interesting things. First of all, is that if you can see the change in the profile between that of Bacteroides bifidobacterium and that of Prevotilla is not the on-off kind of 1 and 0 kind of changes, but rather the changes is gradual and regional as well. And can you see here that the orange color decreased towards Central Asia, and on the other hand, the green color, which is Prevotilla, increased towards Southeast Asia, which strongly suggests that the changes, the microbiome profile is not determined by one parameter, one factor, but rather by multi-factors parameters which interact with each other, affecting, influencing the gut microbiota profile, and therefore we change this gradual shift in microbiota with region and even within one country. So that's interesting. And the question, of course, comes as to what are the factors that could actually affect the microbiota profile, since it is important, as shown in other works, that they actually determine the health and well-being of individual and in the development of our functional physiology, such as immunological functions, mental functions, and others as well. Earlier work has suggested that the diet is the main factor, and it suggests that there are 3 enterotypes. Those who consume a lot of meats and saturated fats are predominant in Bacteroides, and those who consume food diet rich in carbohydrate favor Prevotilla. So our data seem to agree with that, in the sense that the Eastern Asia consume more meat than the Southeast Asian consume more plant-based product. That is agreeable in this sense. But however, interestingly, when we further analyze the microbiota of the Asian people, there are 2 exceptional, which we think tell us a lot on the microbiota profiles and its distribution. One is the Mongolia. Mongolia, despite of being in the northern hemisphere, and you will see the data. I'll show you that Mongolia actually consume a lot of meat. It's probably common sense as well. They consume a lot of NAM, basically. However, the microbiota profile, the enterotype is very similar to that of Southeast Asia. That is that you have a large sections of proportion of microbiota in Prevotilla cae. That's out of the place. And the other one is the Indian subcontinent. There are people in Indian subcontinent consume who are vegetarian. However, there are people who are meat eating as well. Nevertheless, even among meat eating people, you can see that this large proportion of Prevotilla cae, Prevotilla, among the microbiota, same as Southeast Asia. So this we found most interesting. So the working hypothesis, the interpretation, or rather interpretation of Asian microbiota profile based on our observation in Mongolia is that, all right, as observed in the West and North America and Europe, the meat eaters are high in Bacteroides. And however, in Mongolia, consume large amount high meats as well. In fact, is second to that of USA. However, the predominant microbiota is Prevotilla. And when we start to analyze the diet carefully, we realize that something unusual stands up. That is that Mongolia consume the carbohydrate staple food as mainly consists of high resistance starch, such as that in barley, buckwheat, millets, so on, which contain a large amount of resistant food, which, i.e., they cannot be digested in our intestinal tract fast, just a long residence times in intestinal tract. So the working hypothesis we have is that, all right, the fat itself in the diet induces production of bile acid. This bile acid is going to suppress that of Prevotilla and other bile-sensitive bacteria, thus allow Bacteroides, in particular Bacteroides fragilis, to proliferate. On the other hand, among the Mongolia and in Southeast Asian, the staple food carbohydrate consumed are high in resistant starch, such as that indica rice, which is high in that of resistant starch, such as barley, wheat, and millets, and so on and so forth. And because they are long resting times in intestinal tract, they absorb bile acid on them and thus reduce the free bile acid contained in the guts itself. Thus, the Prevotella are allowed to proliferate, and as a result, the Prevotella suppress Bacteroides fragilis and other of that. And thus, the Mongolian, the Southeast Asian, has the predominant microbiota of Prevotella types. This working hypothesis based on the assumption that the Bacteroides is not promoted by meat eating, but rather that it is the Prevotella that inhibit Bacteroides. Thus, when a person has a suppressed or low Prevotella, Bacteroides are allowed to proliferate based on observation and analysis of diet among Asians. Could this be true? We try to verify that by following the microbiota profile of Mongolia over 40 months, actually 1 year. The reason is that Mongolia consume high meats, animal fats, and animal meats and fats in winter. However, in the summer, their diet are free of meats. The diet main components are dairy products, cheese, milk, sour milk, and so on and so forth. In this case, if indeed meat determine the microbiota type, we should observe changes in a Mongolian microbiota over that of summer and winter. However, we did not see that over the year. Bacteroides maintain relatively constant in the content, and Prevotella maintain relatively constant as well. It is other that, for example, lactobacillus and so on, that change. Thus, seem to strongly suggest, or at least confirm or suggest that Bacteroides is not really determined by meat eating, but rather it is the Prevotella that allow the Bacteroides to grow. So that is the observation we have. Then it comes the other exception in the microbiota profile. That is the Indian subcontinent, which is high in Prevotella as small. So the diet they have, in fact, is no different from other part of Asia. The meats, the vegetables, the rice, and so on and so forth. And what caused the difference then? One thing stand out, and probably all expect, is that Indian foods are high in spices. They have a lot of, include a lot of spices, and the most well-known one is the curry. In fact, many Southeast Asian countries consume curry and spices as well. So we assume that spices is a main moving force in determining microbiota, beside that of the meats and that of vegetable staple food and so on. So we conduct an intervention study where we give curry either at 6 grams per day or 12 grams per day. For the reason is this amount of curry people consume the highest or lowest amount. And to Singapore, Chinese who doesn't consume curry at all. And interesting, straight away can see that 3 groups of microorganisms are being affected in the gut. First of all is that with the consumption of curry, Bacteroides is being suppressed even a small amount, 6 grams per day. And Prevotella as well, it increased correspondingly. Whereas Bifidobacterium, only when one consumes high curry, 12 grams per day, then the amount is enhanced, increase. So this does tentatively explain the enterotypes Indian subcontinent. And the question then is that besides that, other factors such as lifestyles, ethnicity, and so on affect the gut microbiota. We thus conduct a study comparing gut microbiota of Southern Chinese and Chinese in the Eastern Malaysia, these are and Western Malaysia, and that of local Malay population. In Eastern Southern Malaysia, this is because the Eastern Penang is a big city, whereas the Kelantan is the rural area. And you can see here on the right hand side, to cut long story short, is that obviously you can see that Chinese population on top here, the red one and green one, 2 Prevotella Bacteroides predominant population, is different from that of Chinese in Malaysia. And whereas the Chinese in Malaysia, Malay in Malaysia, and the big cities and the rural area are all overlap with each other. Thus, strongly suggests that diet is the primary factors, whereas lifestyle, ethnicity, these are secondary factors in determining microbiota. Then follow important question. Since we know that gut microbiota is determined by diet, and you can choose what microbiota you want actually, either Bacteroides, Bifidobacterium, or the Prevotella, each has advantage because Bacteroides and Bifidobacterium has been suggested to modulate immunological development, to suppress pathogens and so on, whereas Prevotella help to digest carbohydrate and so on and so forth. But more important, as listed here, both of them are associated with diseases. Bacteroides is independent high-risk factors of arthritis, arterial diseases, type 2 diabetes, colon cancers, and so on and so forth, whereas Prevotella is associated with bacterial vaginosis and others, fatty liver, and so on and so forth. So which one do you choose? Either one is going to give you problems. So we ask the question, can we actually modulate our diet?
You have 1 minute left.
All right, I'll finish it straight away. Modulate our diet so that we can have enough amount of bacteria to modulate our physiological development, yet not enough to cause this side effect. And it turned out to be the answer is yes. Because when you analyze Singapore microbiota, we find that there's a population of people who consume Western diet contain a high 30% of OTU in Bacteroides. The population consume traditional Southeast Asian diet, predominant Bacteria. And there's third cluster who doesn't have predominant organism at all, or quite evenly distributed. These are the people who change diet frequently every year, every day, every meal, Malay, Indian, Chinese, and so on and so forth. They therefore doesn't have this predominant organism. And surprisingly, this group of people, the microbiota is extremely stable despite of not having predominant microorganism. For reason is that in fact, it's a bit like the secondary forest where the big trees clear off, the bushes grow, overgrown, and bushes grow very fast, and therefore they are very stable. So all in all, with this short presentation, I hope to impress you that in fact, the microbiota is important and understanding is most interesting, and Asian represent an area where, because of the diverse ethnicity, dietary habit and culture and so on, a model for us to understand our microbiota and the association with health diseases. Thank you very much.
Right. Thank you very much, Dr. Lee, for a very insightful talk. So now we need to have a question for Dr. Lee now. So anybody's from the floors online.
I actually have posted my question here.
Okay. All right. Is enterotype determination reliable to determine the grouping?
Enterotype is reliable in determining,
in grouping and in looking at the differences between populations.
Enterotype is only a term. In fact, we don't prefer enterotype. Perhaps it should be microbiome clustering, for example. For reason is that where is the cutoff? Because the enterotype implies that either you have this or that. It means either you have Bacteroides or your Bifidobacterium, or that you have Prevotella. In fact, we don't see that. Even within one country, for example, in Thailand, where you're residing, or Indonesia, the microbiota ratio between the two major groups change gradually among people. And therefore, I'm not sure whether I answer your question, but the thing is that my gut feel, and perhaps want to hear your view, is that enterotype perhaps not a good term, rather the clustering, and perhaps we should also, perhaps we could design a term to describe these gradual changes and where we should base our definition, since there's no clear cutoff.
Thank you, Yuan Kun.
Okay, any more questions? Okay, maybe I have a question for you, Dr. Lee. So seems like, when we try to associate the diets with the gut microbiomes, when the information keep on more complicated, even a spice, let's say, can influence the type of microbiomes. In such case, when we think of the very high diversities of diets in Asia, so
Yes.
you can see the direction what will going on in the futures. I mean, how many data or how many information that we need to trace and then try to find in order to make some insight of this gut microbiome in Asian people.
Yes, the question is more interesting. In fact, this is one of the things that we're trying to look into, but it's not easy. The gut feel, looking at the profile and so on, you can have this feeling that eating something with spices or meat or fat or plant or so on, does have some influence. So is it possible to construct mathematical equation, quantify the influence of each component? And in some cases, we seem to successfully predicting that, which means that you have certain weighted influence of different diets, and they add them together, they give you a general profile of the individual. So I think with meta data analysis, big data analysis, we would be more accurate in formulating this quantitative relationship. They will allow us to more accurately predict the gut formation, gut profile, microbiome profile by eating different things. And more importantly, the question perhaps answer and the thing we should know is that how does this profile affect our health and diseases? And if you can quantify it, then you can more accurately actually predict and pinpoint. So that is, I think, interesting direction that we wish to go into, and perhaps that we should work together to do that. So sorry, I see that there are 3 questions. Could you possibly help me to read out, because while I'm reading, difficult to think is on. Could Chairman, can you please read the question to me?
I don't see more questions in the chat box.
Oh,
so,
okay.
Parina, you see one?
No, and you have answered my question already.
Right.
Thank you.
Okay.
All right. I think it's for the time. All right. Thank you very much for Dr. Lee.
Thank you, and I hope to see you in person and hope to
yes, visit us again one day.
Yes.
Thank you, and have a nice day.
Bye-bye.
Bye-bye.